So, good morning, all. This is our fifth to last unit in our digital logic and computer organization, just nothing but memory and the HIVO. So, first of all, we have to discuss about the memory, what are the main concepts in the memory, how the data is stored or processed, and how, based on the different types of memory, how we are able to hierarchy the memory structure. So first of all, memory. Memory in a computer storage plays a vital or a crucial role to store and perform the operations on the system. So if you want to process or perform any of the operations in the memory, everything data as well as the instructions should be stored in the main memory. So that is why the memory plays a vital role. So first of all, the memory in the computer storage is hierarchy based on the size and the efficiency and the processing speed cost. Everything we have to consider when we have to hierarchy different types of memory. The first at the top of the hierarchy is the registers. Registers is nothing but is made up of number of flip-flops and flip-flops. It is the fastest as well as the smallest memory units located within the CPU. So everything we have to execute the operation, the every data and instruction should be loaded in the main memory, then only it perform the execution. So in that cases, each and every data as well as the instruction should be stored in the memory in terms of the registers. So the main memory holds currently running programs which has a capacity larger than the cache. So now what is cache? The cache memory, which is nothing but a intermediate memory which holds the immediate data or frequently accessed data for the particular execution of the operations. It is at the bottom of the secondary storage is the hard drives as well as the SSD, which provide a large and the permanent storage but operate much more slowly. So this is what the memory hierarchy and the main concepts of the memory. So there are two different types of memory hierarchy. In memory hierarchy, external memory or a secondary storage, internal memory or the primary storage. First of all, we have to discuss about the external memory or secondary memory. So the examples of the secondary memories are optical disk, magnetic tape, etc., which is accessible by the processor via the IO model. Just nothing but a communication bus. For the main intention of using the secondary storage is permanent. It is a non-volatile memory. But in case of internal or primary memory, this is a permanent one, is a temporary one as well as the volatile memory. The examples of the internal or primary memories: cache memory, CPU registers, and main memory. But if you want to the main difference between the external and the internal memory is, if you want to execute an operation in the inside the computer, every data which is present in the secondary memory which is loaded into the main memory, then only the CPU or a processor get executed. This is what the main difference between the external as well as the internal memory. So this is what our memory hierarchy design. There are 5 different levels or 6 different levels in the memory hierarchy design. The last at the bottom occupies by the secondary storage is nothing but the magnetic tape as a optical disk, magnetic disk, main memory, cache memory, and CPU register. So when we move from downwards to the upwards, it increases its cost per bit. From when you have to go move from up to down, increases capacity and the access time. In case of level, the difference between the among the level 5 and 0 is the level 5, that is the magnetic tape, occupies a large amount of data when compared to the CPU registers. The CPU registers hold the data based on number of flip-flops which is used to design the CPU register. So the increase in capacity and the access time is increased from upwards to downwards here. And the cache memory is SRAMES, is a static random access memory. It holds only the frequently accessed data for processing. It have to place between the CPU register as well as the main memory. If you want to access the number of instructions from the main memory, frequently access main memory, the accessing time might be increased. In that purpose only, we have to design a cache memory which holds the frequently accessed instructions or a data for a particular process during executions. And as well as the level 3 up to level 5, it is the overall the secondary storage devices which can able to hold an number of data, a huge amount of data which is a non-volatile. So first, the first three levels needs power to be used or accessed during the execution. So up to the level 2, they are all volatile memory. The memory hierarchical level, the first one is occupied at the top of the hierarchy is registers. Registers are small but a high speed memory is located inside the CPU, which is used to store the most frequently occur data as well as instructions. It has a fastest access time but has a small amount of memory to hold. It can able to store the storage capacity for the register ranges between 16 to 64 bits, and the cache when compared to register, it able to hold a large amount of memory and frequently used instructions for the faster access and the processing speed without the need to without the need to randomly fetch the instructions from the main memory. So main memory, that is random access memory. It's a primary part of the computer system. It can able to store a large amount of data when compared to registers and the CPU, but it is slower when compared to this two. So these are different types of RAM. The first one is SRAM and DRAM. SRAM is nothing but a static random access memory. It is a volatile memory, and DRAM is a non-volatile memory. So the DRAM can be further divided into various types: ADRAM, SDRAM, DDR, SDRAM, RDRAM, CDRAM. So now we are going to see about the different types of main memory. So first one is the static, the second one is the dynamic. So in this case of static, it stores the binary information and the flip-flops. The flip-flops are just used to build for the number of registers as well as the counters, and the information in this type of static RAM will remain until the power is supplied. Once the power connection gets off, the entire data which is stored in a static memory or a static RAM will get erased. For that purpose, we are going to use to design a secondary storage memory. So but the main advantage is the faster access time, and it is used in implementing with the help of the cache memory. So the next one is the dynamic RAM. Dynamic RAM is also store the binary information based on the capacitor. So capacitor is also one type of memory element that is used to store the memory data or instructions. It requires refreshing circuitry to maintain the charges. Why we are going to use a capacitor means we have to give the constant power supply to hold or to remind the data which is present in the dynamic RAM for a few milliseconds. When the power gets cut off, it is used for backupping the data when the power is unfortunately gets switched off, and it contains more memory cell as compared to the SRAM. So the secondary storage devices, just nothing but hard disk drive or a solid state drivers, which is SSD. As we can said earlier, it is a non-volatile memory. It has the largest storage capacity than the main memory. Of course, we can able to use the extension devices for that, and we have to use extended main memory as we have required. Okay, able to reprogram it, and it is used to store the instruction and data that is not currently used by the CPU. Which means when we are going to execute any of the process in the computer, every data and instruction should be held in the main memory. So what are all the data which is not currently used by the CPU, we can able to hold it on the secondary devices. And the next one is magnetic disk. The magnetic disk is simply a circular plate which is fabricated either with a plastic or some other magnetized material. So the magnetized material is needed to hold the data for a long time without any loss of the information. The magnetic disk work at a high speed inside the computer, and they are frequently used. So the next one is the magnetic tape. The magnetic tape is a recording tape which is covered with a plastic film, which is used for holding the backup data, as well as we have to, if you have to store, if you have to maintain a large amount of data, we have to able to store in the magnetic tape. So the access time for the data which is holding a magnetic tape is slower because it is placed in the level 5 hierarchy. When we go with the top to bottom, the accessing time will get reduced due to the large storage capacity, as well as it needs a large control signals, or you have to fetch the data from the secondary storage. So the next one is the characteristics of memory hierarchy. How the different types of memories are placed in the different levels based on certain criteria. We have to categorize the characteristics of memory hierarchy. The first one is the access time. So the if you want to execute a process, the access time for the data as well as the instruction should be faster. It is possible only when the data and instruction should be stored in your memory, main memory. So that is why the register is the faster, because the register is located inside the CPU. So that is why the access time for the data and instruction from the register is faster. That's why it occupies the top position of the memory hierarchy. So the next one is the capacity. Based on that capacity, we have to segregate different memory levels into five. The storage capacity should be large for holding a large amount of instructions, but in case of the main memory, it stores only a few amount of data only. So in that case, the secondary storage, we are going to deal with the secondary storage to store a large amount of data. Cost. So cost, the every must memory element should be a cost effective. In that cases, the register should be very costly, because each and every register should be made up of n number of flip flops. It can able to hold only a single memory element. So that in that way, the capacitor, the register is a little bit cost when compared to the secondary elements. And locality of reference. The locality of reference means that the program has the tendency to access the same data and instruction repeatedly. This is what the locality of the reference. For the frequently accessed data, we are going to design a cache memory which is store the frequently used information for the particular execution of the program. The next one is the memory management. Now we are able we are see about the different memories and the hierarchy of the memory. Now how this memory have to be managed for the successful execution of the program. The first one is the memory management. Since the main memory is limited to hold the data, and we have to use n number of secondary storage devices for holding the data. For that purpose, we have to manage the memory efficiently to increase the processing speed, and also without the need to start any of the program for or for waiting for the data to be accessed. To enhance the performance, several process must be reside in the memory simultaneously. For example, if your computer running n number of processes simultaneously,